8518. Okay. Robo Warriors, go ahead.
So our project is on the nanobots for usage in the treatment of blood clots. When someone forms a blood clot in an easy to access area, doctors right now use cut and sew operations. But in a more difficult to access area, they use cardiac catheters. However, these catheters are hard to control and they can prick artery walls, causing fatal bleeding.
Scientists solved the problem by using a nanobot to go inside the body, then identify the blood clot, and then release the anticoagulant medicine to resolve the problems.
We chose the topic of nanobots because when we researched, nanotechnology was a very rising subject. So we wanted to see how a nanobot would be used in the help of medical sciences. We were surprised to see how such a small thing, 10 to the power negative 9 meters, could go inside a person's body and fix such major problems.
We decided to talk about nanobots resolving blood clots because in the past, our relatives and elders have gotten cerebral attacks and heart attacks. So we asked our parents why, and they said it was due to blood clots. So we thought, how can a nanobot be used in this situation? Maybe it can go in the artery to dissolve the blood clot.
Blood is a fluid that has red blood cells, that has oxygen and nutrients, and hemoglobin. Hemoglobin is iron and protein. It has white blood cells that face infection and platelets that clogs the blood.
A blood clot is when platelets and fibrinogen combine, which makes a chemical reaction and then makes a blood clot.
Nanobots aren't actually electronic robots at all. Nanobots are actually made up of organic compounds. Scientists have come up with a way to create nanobots in a diamond structure made out of carbon atoms, which would give the nanobot inert strength. Nanobots are called nanobots because they're built to the scale of nanometers, or 10 to the power negative 9 meters. Nanobots are artificially created.
To identify a blood clot, you have to use 3 markers. One of the markers is using a color sensor. While using a color sensor, you have to use the 3 primary colors, red, green, and blue. If you put them in any proportion, you can make any color. So while using a color sensor to identify if it is coagulated blood, which is a brownish color, or normal blood, which is reddish color.
Normal blood has less density than coagulated blood. Normal blood's density is 1.05 grams per centimeter cube, and coagulated blood's density is 1.60 grams per centimeter cube.
You can also use a densitometer to help find the density of blood clots in regular blood. Another marker is by using iron. A blood clot has a higher concentration of iron than regular blood. You can use an iron detector to detect that concentration and find which is the blood clot and which is regular blood.
To get close to the blood clot and identify it, the nanobot first needs to move. So, scientists have come up with a sort of enzyme motor that would be placed inside the diamond structure mentioned before. That enzyme motor would use enzymes to break down glucose and create energy. That energy would then go to a flagella-like structure at the back of the nanobot, shooting the nanobot across the person's bloodstream toward the blood clot.
While the nanobot is placed by the blood clot, it identifies it and then releases an anticoagulant medicine to help dissolve it.
Here's one way we visualize the nanobot. Here is the flagella and enzyme motor. Over here is the medicine that goes into the injector to dissolve the thrombus, and here are the sensors.
Our original problem was that catheters would prick the artery walls, so we thought of a non-invasive way to remove a blood clot.
We thought of using a nanobot that would use an enzyme motor and flagella to get to the blood clot, then use the 3 markers to identify the blood clot, and finally release anticoagulant medicine to dissolve the blood clot. All of these concepts that we've talked about have already been created, but no one thought of putting them together into a nanobot to use it for this specific problem. Any questions?
Where did you come up with your research?
Well, we searched the net, and we found a few sites. One of them was called WiseGeek, which talked about the structure of the nanobot, the diamond structure, and it talked about what scientists already planned for the nanobot to do. Then there was another one called Nanogloss, which talked about the enzyme motor that I mentioned before. All the other sites are in the workout.
Are these the same? Are these all the same? No.
There's a write-up.
Okay, this is the write-up. Okay. And have you presented this to anyone else yet? Have you?
We have done a demonstration at our where we practice every Saturday. We've done one demonstration with the same project, but that's all.
To one group.
We're probably going to do one at the South Plainfield Public Library.
Good. Excellent. Anything else? Let's see. Have you presented to your school, with other people within your school?
We have presented to the people at his school, but nowhere else.
Okay. You made a couple of presentations. That's good.
What made you think about this?
Um,
Like, we found on the internet, like, everybody individually found research and found information. So they mixed it up and like we put it in different orders, and that's how we came up with the project.
And the first thing we do to choose this, in the beginning we had two topics that we all came up with. One was bionic arms, and the other was the nanobot. And we considered it and thought that the nanobot was more interesting, so that's what we go for.
It is very interesting. Did you talk to any live bodies that came in to talk with you? Yes?
My dad has a friend, an expert, Dr. Subrata Saha, and he came in and talked to us about this topic and explained some stuff.
Okay.
What did he think about your
He's
idea?
an orthopedic scientist and like a doctorate of orthopedics, and he came in with his wife, Pavana Saha. She's a psychiatrist, and she's talked about like mentally ill.
Well, thank you very much.
Very
It's a
much.
very interesting topic. I've done great research, and you presented without papers. You've done a lot of practicing to present, haven't you?
Thank you.
Thank you very
Very
much.
good.
Thank you.
Thank you for your time.
Thank you for your time.
Thank you, Jayesh.